Okay, so we'll come to a result called map lifting. This is a very important result in its own right. It will also be the way we study all the coverings of a space. So it's a bridge to the Galois theory of covering spaces, but this has applications in complex analysis, for example, of course, together with other ingredients. And this is, we spoke about the lifting problem right at the beginning. This is a almost complete answer, in fact a complete answer in many situations to the lifting problem, provided this is a covering space. So P is a covering map. So I have path connected topological spaces, and then I have a map with, and I also have base points in them. I have a map from here to here, F, and I have F tilde up here, and then I have lifting problem. So lifting problem is asking whether F tilde exists. Okay, so suppose F tilde exists. So suppose F tilde exists, then we get a condition one way. Namely, we can see that F tilde star of pi1 of ZZ0, the image of this group, okay, is going to be, sorry, it's not this way. So let's just look at the images of the group. Okay, so if I look at F star of pi1 of ZZ0, this is the same as P composed with F tilde star of pi1 of ZZ0. Okay, so this is just as an image of group, P star of F star tilde of pi1 of ZZ0. You may wonder what we have achieved if we don't know the map F tilde. We do know something though. What we know is that this is contained in P star of pi1 of YY0. So remember, covering maps induce injections on the fundamental group. So pi1 of YY0 is a subgroup of this, and hence we can see that the image of this being contained in this is a non-trivial condition. In fact, we can take an example here. So example, if I had S1 and 1 mapped by identity to S1 and 1, and I had R, which I know has trivial fundamental group and 0, and this is a covering map. So F tilde, this has no solution. You can see that because the image under the identity map here, or indeed power map if one does a little work calculating things, is going to be a non-trivial group, and so it's not contained in the trivial group, which is the image here. Okay, so this is just sort of classic algebraic topology. As I said, you apply a functor. Now we have some functors with which we can calculate. Of course, we got deeper theorems with that. The key point here is that the converse is almost true. Almost in the sense we need a condition on X, and we'll show in an example you need it. If X is locally path connected, we'll abbreviate this as LPC. I'll define that in a moment. Okay, then F tilde exists if and only if F star of pi1 of ZZ0 is contained in P star of pi1 of YY0. So our necessary condition is actually even sufficient. So this particular functor determines everything, only provided this is a covering map. But this is also a prototype in general. So covering map says the fiber is discrete, and if the fiber is not discrete, it will depend on the topology of the fiber or of components of the fiber, etc. Okay, so this is a prototype of this construction. So let's actually define. For completeness, all local properties are defined this way. Space X is locally path connected if for all, let's take a point in X, and U contained in X open with X in U. So given any point X and given a neighborhood U of that, there exists V contained in U open with X in V such that V is path connected. So not only is any point contained in a path connected neighborhood, given any point in a neighborhood, there's a smaller path connected neighborhood containing that point. This is the crucial condition for the above. We'll have locally various properties which are all of the similar nature. So you say it locally has a property. If given any open set, there's a smaller open set which has that property. Okay, or smaller set which has that property. If you want to say locally compact, obviously you don't want a smaller open set, smaller set which has that property. Okay, so this is the condition under which we have this. Okay, so the proof we'll do in a couple of steps. First step we'll do a construction, and the second step will show continuity, and the first step will not actually use local path connectivity. So let me draw y and x a slightly more interesting example here. Okay, similar to what we have seen. Y is going to be a cylinder. So this is S1 cross R, and you have a cover to x which is a torus, and maybe this belt here goes to this belt here. Okay, so this is S1 cross S1, and you can guess what the covering map is. It's the map P, which was going to map. So you're already in S1 here. So this is, let's call that Z and T. It goes to again Z itself, e to the 2 pi I t. Okay, and then I have my, so this is X and this is my Y. I have my Z, which may be a surface like this. Okay, this is Z, and here is Z0. Here is a point X0. Here's the point Y0 sitting above it. And the first point is so one is we construct F tilde. 2 will be sure it's well defined. Okay, so the construction naively is the following. Naively in the sense of not knowing if this is well defined. We take another point Z here. Well, Z is path connected. Okay, so I'll pick a point. Okay, so given Z in Z, let me say alpha. So this is going to map 0, 1 to Z. Be a path from the point Z0 to Z. Okay, let F tilde of Z. How would I define it? Given this path, I have an image, which is maybe it's a path which happens to go like, well, let's keep this one simple. Maybe it's a path which just goes here like this. Okay, so this is a path here, and this point is X. Well, it is, I don't know what that X is. So this X is just F of Z. We know that. And now we have path lifting. So if this is F, so this path is just F composed with alpha. Okay, and what do? I can lift this starting at Y0. Okay, F composed with alpha tilde, and I'll let Y equals F composed with alpha tilde 1. F tilde of Z equals F composed with alpha tilde 1, where whatever beta tilde is by definition lift of beta with beta tilde of 0 equals the base point Y0. Okay, so here we have this thing here. Fine, this is all very well, but this is still a very elegant idea that we know we can lift paths, and hence we got a map which sent a point here up there. Namely, I took a path, pushed it forward and lifted it with the correct starting point, and the end point is this. But our choice depended strongly on the path. Okay, so here there's the key point, well defined. By the way, in the first step we used only the set topology hypothesis. We use the fact that these are path connected and that P is a covering, but nothing about the fundamental groups. Okay, so well defined is now let's take another path. This time let's make things a bit colorful. Maybe I took this path instead, and maybe that path went to something genuinely different, like this one. Maybe it went to something which went round like this. Well, what about the lift? Fortunately for us, this one goes to something which lifts and ends at the same point. It need not. In this picture it does, and under the correct hypothesis it's supposed to. Okay, so what is the hypothesis? So let's call this other path, so this is alpha, let's call this other path beta. Okay, and what do we know about this? We know that if I take alpha beta bar, okay, so suppose beta is another path, and which begins at the same point, ends at the same point, then what we know is alpha star beta bar, this is a loop, and so it belongs to pi 1 of the Z with fundamental group Z naught. Okay, so this means that F composed with alpha star beta bar, so this class, okay, it is going to be an element in pi 1 of our xx0. Okay, but this pi 1 of xx0 is but we know more than that. Okay, we know it's also an element in p star of pi 1 of yy0. Okay, so what does this imply? Hence we can see that F composed with alpha, and I'm going to write this out as F composed with alpha star F composed with beta bar, okay, is an element here. Okay, so it can be written, so this guy can be written as P star of some curve upstairs. Let me call it theta tilde. Okay, tilde because even though it's not a lift, it's a loop. So theta tilde, take the class of this. So this tells you that this F is homotopic to theta, which is P of theta tilde. Okay, so theta tilde is a loop. Okay, from this you can deduce by starring by F composed with delta that FO tilde is homotopic to theta star F composed with beta bar. Okay, not beta bar now, this becomes just beta because it's the inverse of that, which implies that if I look at FO tilde 1, okay, that is equal to theta star F composed with beta tilde 1. Now in the past also we have taken lifts of such products, and the point is as soon as you have one lift which is continuous, you know it's the correct lift by uniqueness. But now theta tilde is a loop that begins and ends at y0, so I can multiply this by F composed with beta tilde of 1 because this also begins at y0. Okay, and so this is the same thing as F composed with beta tilde of 1. So what we have deduced from this is that whether I took the curve alpha or beta, we end up with the same curve at the right end point. This guy is the same curve, same point at the right end point. Okay, this tells you F tilde was well defined. This was our first non-trivial point here. Okay, so the next segment we'll see that this is in fact actually continuous. We'll look at the same picture and see this.